The title of this work is A Mechanistic Physiologically Based Biopharmaceutics Modeling Approach to Evaluate the Role of Dissolution on Fexofenadine Absorption from an IR Tablet Formulation. Fexofenadine is a non-sedating antihistamine drug mainly used for the treatment of allergic rhinitis. According to the biopharmaceutical classification system, this drug is considered to be the borderline between class 3 and 4. The aim of the study was to use a mechanistic, physiologically based biopharmaceutics modeling approach to evaluate the role of drug dissolution on intestinal absorption of fexofenadine from an IR tablet formulation in comparison to the reference product Allegra 180 mg. A test formulation of immediate-release tablets containing 180 mg of fexofenadine hydrochloride was prepared. The solution test was evaluated using apparatus 2 at 50 and 75 rpm and 900 milliliters of 0.001 milliliter of hydrochloric acid. The software used was the GastroPlus. The modeling and simulation steps involve model development, verification, and application. The first one consisted of the model development using in vivo intravenous administration data from literature and experimental data to build a 3-compartments model. The model was double verified with data extracted from the literature and the results obtained being a guarantee of reliability of the pharmacokinetic model developed. After the success of the verification, in silico studies were conducted. Finally, a virtual bioequivalence study was conducted to compare the performance of the developed test formulation and the reference drug. For comparative purposes, a mathematical relationship between observed and predicted data was applied. The success criteria. The figure shows the dissolution profiles of the reference drug Allegra 180 mg and the test formulation. During the test, Kuhn formation was visually observed. In order to minimize the impact of this phenomenon, tests were carried out applying a rotation speed of 75 rpm. For the test formulation, a release of about 95% was obtained in the 10 minutes of testing. Furthermore, the increase of rotation visually minimized Kuhn formation. This graph shows a comparison between the predictive plasma curve using the pharmacokinetic model developed and the observed plasma curve. The R2 obtained between the predictive and observed curves was 0.995. And the table shows the predictive and observed pharmacokinetic parameters, and when comparing the values, it is possible to conclude that the model is adequate because of the predictive values are within the range of the success criteria. The pharmacokinetic model was used to predict the plasma concentration versus time curves from the experimental dissolution data of Allegra 180 mg tablets and test formulation. Evaluating the results shown in the table, it is possible to infer that the correlation made is acceptable. Experimental data from the dissolution test carried out with rotation speeds of 50 rpm and 75 rpm were evaluated in the virtual bioequivalence study. The results referring to the two tests reveal that the formulation is considered bioequivalent in silico, because the values of Cmax and IUC are within the range of 80 to 125%. PBBM allowed a mechanistic understanding of fexofenadine dissolution. Since very rapid dissolution was obtained, drug absorption showed to be more dependent on permeability and intestinal transporters rather than dissolution. I would like to thank Simulations Plus for providing the GastroPlus software, the co-authors and collaborators for the contributions, UniFASP for the support, and FAPAS for the grant. Thank you for your time, and if you have any further questions, please feel free to contact us.